Good morning. My name is Monil Lakhotia and I am the team leader for this presentation. I am joined today by my group Medtrack along with my fellow group members, and together we will be presenting a project on pharmacy management system. The purpose of the presentation is to provide you with an understanding of what pharmacy management system entails and the importance of such a system in the current digital age. We'll cover the objectives, problem solved, modules used, and provide UML diagrams to help you better understand the working of a model. Pharmacy management system is a software that stores complete information about the processes in a pharmacy. It helps in storing data, organizing the entire system, and automating workflows to reduce operating overheads and minimize error. While pharmacy management systems can help you in tracking medication usage and inventory, it is important to note that the ultimate responsibility for controlling medication use lies with healthcare professionals such as pharmacists and doctors. We hope that by the end of the presentation, you will have a better understanding what the role of pharmacy management system and how it can benefit the pharmacy industry. So, without further ado, let us begin. Pharmacy management system main objective is to process the billing and clear data saving in effective and time-saving manner. The pharmacy system also reduces errors. Some of the resources are cancelled, such as papers, some resources are minimized, such as manpower and related things. From here, my team member Karthik will take over.
Pharmacy management system solves several common problems faced by pharmacists and pharmacy staff. These include manual data entry errors. With a pharmacy management system, much of the data entry is automated, reducing the risk of errors caused by manual entry. Prescription processing delays. The system can streamline the prescription processing workflow, reducing wait times for patients. Patient safety concerns. The system can also help to ensure patients are receiving the correct medications and dosages, reducing the risk of medication errors. Overall, a pharmacy management system can help to improve the efficiency, accuracy, and safety of a pharmacy's operations, leading to better patient outcomes and a more successful business. Now onto the modules. This is a pharmacy management system code written in C++. The program uses a class named medicine type to declare the functions used in the main menu. The class has six functions corresponding to each of the options in the main menu. The class also has a constructor function. The six options are: first, take new medicine order. In this, the program takes input of the type and total number of medicines required by the user. The user can order multiple medicines simultaneously. Second, delete latest medicine order. This function allows the user to delete the latest input given or to remove a particular medicine. Third, modify order list. These functions allow the user to add or remove particular items from the list. Fourth, print receipt and make payment. The code uses this function particularly for the billing process. The order given by the user and total amount to be paid is presented in a systematic way. Fifth, daily summary of total sale. This function helps the pharmacy to keep track of total medicines sold, total income, as well as total stock remaining. Sixth, exit. The main objective of this function is to help user to close the program after using it. The linked list is implemented using a struct named node. The struct contains the detail of each medicine order, such as receipt number, customer name, date, medicine names, medicine prices, and quantities. The struct also has three pointer variable for linking the nodes of the linked list. In the main function, the program uses a do-while loop to display the main menu repeatedly until the user chooses to exit. Thus, through this code, we have tried to form a basic framework for management operations, but it does not store the data permanently. From here, Shreyanshi will continue with UML diagrams of the project.
This is an activity diagram for pharmacy management system. Activity diagram shows sequence of actions or flow of control in a system. It starts with a filled circle that notates initial state of the system. Then an activity is represented using a rectangle with rounded corners. Action flow is represented by an arrow and a fork node is used to split a single incoming flow into multiple flows. Also, a join node joins multiple flows into a single flow. Now, in this activity diagram, we start by logging into the system. Then we place an order, then manage the order, and all these activities are represented using rounded rectangles. After that, four options are displayed using fork node notation and the customers can choose as per their needs. And then one can log out from the system, which is the final state represented by a filled circle inside another circle. Next up we have state chart diagram, which represents the conditional part of the system at finite instances of time. The initial state is represented by a filled circle. State with rounded rectangle represents condition of a modeled entity. Then transition is indicated by an arrow which shows transition from one state to another state, and a self-transition arrow pointing back to state itself is used when the state of object does not change upon the occurrence of event. Lastly, a final state is notated by a filled circle inside another circle. In the given state chart diagram, we'll start by logging into the system, then placing order, specifying number of medicines, then drug ID verification. All these are conditions which are represented in a rounded rectangle. Next, if the drug ID is not verified, then again we have to go for the same. Then quantity of required drug is specified using a state, and if one wants to modify the order, they'll have to place an order again. And this transition is represented by an arrow pointing towards placing an order. Also, if quantity exceeds, one has to specify the quantity again, and this is represented by self transition arrow. Further, we can make payments, then log out of the system. Now, Siddharth will explain you further diagram.
So this is a sequence diagram. A sequence diagram is a type of UML diagram that illustrates the interaction between objects in a system over time. As you can see in this diagram, we have three objects: the user, the pharmacy management system, and the order or bill. The arrows between the objects represent messages being passed between them. The user initiates the process by requesting a new order from the pharmacy system. The pharmacy system responds by asking the user for the necessary information to create an order such as patient's name. The user provides the required information to the pharmacy system. The pharmacy system verifies this prescription and confirms it with the user. The user, once logged in, can now create a unique order by adding medicines. He can also edit this later. Once he is done with the editing and he has saved his order, he can now proceed to pay the bill. So, what is the result of all this? Let's see. So, this application is the result of the code of the pharmacy management system. This runs the pharmacy management system, and as you can see here, this displays the main menu where we have the commands where we can take a new medicine order, delete the latest medicine order, modify order list, print the receipt and make payment, and daily summary of total sale, etc. So now let's enter the command, which is command 1, because we want to take a new medicine order. So now we can type the order number. Order number here would be 1. Let's say 1. Customer name would be, let's say, Sid. Date would be 12.04.2023. How many medicine would you like to order? I would like to order only one for this test case, and enter your selection, which here would be, let's say, aspirin. I would like to order only three tablets. Here is this thing. This pays the amount which I would need to pay once I go to the payment section. And as I said, only I want only one medicine. The order is taken. Now it is prompting me to go to the receipt menu to pay the bill. But before that, we can do some changes, because let's say I'm not happy with my order, so I can delete the latest order by the second command. So enter the data you want to delete. So I want to delete my which was order number one. So the receipt is deleted successfully. The receipt which we made here was deleted successfully. So because it is deleted now, we will have to make a new list. So let's make a new list now, and the order number be 11. The customer name, let's say, would be Prabhas Sekharan, and the date would be 30/04/2023. So how many medicinal order? Only one for this test case. Selection would be one dolo for your well-being, sir. And how many medicines would you want? So I would like only two tablets, and here this displays the required amount which I would have to pay. And my order is taken successfully. Now I would continue. I can modify this order list as well, but in this case I don't want to modify. But let's say that we want to modify. So let's go to the modify list case. The receipt number which was here 11, and change the order number. I don't want to change the order number. I want it to be 11. Change the customer name, which I don't want to change, so I will let it be Prabhas Sekharan. And the date. Let's change the date. The date would be 01 dot 05 dot 2023. How many medicine would how many new medicine would you like to change? I still want one medicine, and my selection would still be the Dolo, but we can change it. Let's go for the aspirin. Take 9, and I would want two tablets only. It has displayed me the required amount, and my record is modified. Now I can print the receipt with the fourth command. The receipt number was 11, and my required bill is now displayed. I would have to type the exact amount which I would need to pay, and the required amount is 26. Let's type 26, and payment is done. Obviously, it's not done, but yeah, it's done. So, what all this is a good thing for the user. The user can interact with the software, but for what we have this special option that called the daily summary of total sale, that is made for the pharmacist. So how does it work? When we press 5, this shows the daily summary. Like today we only had one bill, which was for Prabhasekhan sir. If we had multiple orders, it will tell us multiple orders. So it's all done. Now let's exit the system. As we have exit, it says thank you. Press.
In conclusion, pharmacy management system makes the pharmaceutical store work better by being more accurate, safe and efficient. The system was created to make sure the information is kept safe in the records and pharmacy are reliable when customers access the services. The developers collected data and analyzed it to create a new system. After testing, the new system was found to be working well and produced good results. The new system will prevent information from being lost like the old system and will also process the information faster. Here are some recommendations like code can be expanded to include more information like specific services provided by the pharmacies. DRGS diagnosis related groups classify patients into groups based on their diagnosis to help determine appropriate treatment and payment. Location based code identify where the service was provided. Patient information includes details about the patient such as age and gender. Service modifiers give more detail about the specific service provided. Procedure code identify medical procedures and service provided to the patient. Thank you for paying attention to our presentation. I hope you like the pharmacy management system by Medtrack.